Hi, today we are explaining Bohr atomic model and their postulates. To overcome the objections of Rutherford atomic model and to explain origin of lines on a hydrogen spectrum, Niels Bohr proposed his atomic model. This atomic model is based on the quantum theory for revolving electron around the nucleus. Now we have discussed about the postulates of Bohr theory. This is a nucleus. Around this nucleus, the orbits are there. The electron revolving around the nucleus with definite velocity in a certain fixed closed circular paths are called orbit. Out of the infinite number of closed circular orbits around the nucleus, the electron can only revolve around the nucleus in an orbit whose angular momentum mvr, whose angular momentum is an integral multiple of the factor mvr equal to nh by 2 pi. Here m is the mass of electron and v is the velocity of electron and r is the radius of orbit, radius of the orbit, and n is the principal quantum number and h is a Planck's constant. Its value 6.625 into 10 to the power of minus 34 joule second and 6.625 into 10 to the power of minus 27 amp second. As long as the electron revolve around the nucleus, it neither loses energy nor gain energy. Hence, these are called stable orbits. Stable orbits or energy states. Each energy state has a definite amount of energy. Each stationary orbit has associated with definite amount of energy. And these are numbered, energy levels are numbered n equal to 1, 2, 3, 4 and so on from the nucleus. They are also designated by K, L, M, N and so on respectively. The energy of an electron does not change. If the energy of electron is changed when an electron moves from one orbit to another orbit. The outer orbits have higher energy while inner orbits have lower energy. The energy is absorbed when an electron moves from ground state to is nothing but inner orbit to outer orbit. This is the ground state and this is the excited state. If the energy is absorbed, the electron moves from inner orbit. This is called inner orbit to outer orbit. Energy absorbed. When the energy is emitted, the electron jumps from outer orbit to inner orbit. Energy is emitted. The amount of energy emitted or absorbed in a transition is equal to the difference of energy of the two orbits. That means E2 minus E1. Here E1 and E2 are the lower and higher orbits energy. And this one we can write like this. This is an Bohr quantum. This is an Bohr quantum condition. Change in energy we can write delta E, that is nothing but E2 minus E1, and is also h nu. Here the energy emitted or observed in the form of quanta. The energy emitted or observed in the form of quanta. And the last point, the centrifugal force of revolving electron in a stationary orbit, whatever it may be, you have to take that the stationary orbit or this one, what kind of a, so the centrifugal force, it means outward force, the centrifugal force of an revolving electron in a stationary orbit is balanced by the electrostatic force between the nucleus and what is this? Revolving electron. Nucleus and electron. Here the fifth point we are told to that energy centrifugal force is equal to what is that? Electrostatic force between the nucleus and electron is nothing but centripetal force. That's why the electrons does not move. It revolves in a stationary orbit. It neither loses energy nor gains energy. It revolves continuously in a fixed closed circular path. The energy changes only when an electron jumps from higher orbit to lower orbit. This is about the postulates of Bohr theory. And for our next class, we will discuss about the derivations of velocity of electron, energy of the orbit, and the radius of the orbit. We will continue that. Thank you.